So now I should have a CO2 atmosphere, or at least it'll create one. And now we're gonna suck out all of the air. See the gauge over there? You can see that the air pressure is just about to the point where it's would be considered the surface of Mars.
So it is claimed that there is a land way high past the sky, free falling around, called Mars, and it's got an atmosphere of about 5 or 6 millimeters of mercury, which is about 1/10 of 1 psi, and it is claimed that there is a helicopter flying around there. So when I compare that to reality, I see that a helicopter can fly around 5 miles, and helicopters can hover around 2 miles, and high performance helicopters can go a few thousand feet past that. So this first demonstration is from YouTube channel Cody's Labs, and Cody is trying to replicate Mars's atmosphere to show that a helicopter could fly around by trying to blow a feather in a vacuum chamber at about 1/10 of 1 psi. First, let's compare known reality to their story. So we'll give them a couple extra miles and say a helicopter can fly at 7 miles in altitude. And I can't imagine they fly much higher than that, but that's around 3.5 psi. That means the psi in their story is around 35 times less than what helicopters can achieve in known reality. This fan is rated to blow at about 30 meters per second.
Okay, fans on. And the feather's not moving. In fact, let's zoom in on that.
So if we incorporate their story into our reality, we could conclude that near hurricane force winds cannot even blow a feather at 1/10 of 1 psi. Now I'm sure McToon and all his NASA fanboy defense attorneys will say, NASA got a helicopter that blows 1,000 times harder than hurricane winds. Hurricane winds ain't shit. And they'd be full of shit. Because that's the point where the best known jet engines fail to thrust. And the ones that may possibly thrust at that pressure are moving hundreds of miles per hour. So no air, no helicopter. But no matter what we show them, they will defend this fantasy at all costs. Example 2 comes from YouTube channel Action Lab, and I want to say that this is in no way a hit piece against Cody or Action Lab. I do appreciate the tests you guys do. Now, right before this point, he had a drone in that vacuum chamber, and he was pulling out more and more air until the drone could get no lift, which is safe to say is probably around 2 or 3 psi, or around what we just demonstrated. Then he puts a balloon in there and unpinches it to see if rockets would work in a vacuum. But to me, this is a miserable fail because that's nowhere near a vacuum. But let's see what happens.
Okay, so I've lowered it to about the same air pressure that the drone couldn't fly in. So now I'm going to remove the magnets and see if the balloon flies. 3, 2, 1. Look at that.
So to me, that's pretty weak. But what I want you to do is pay attention to when the balloon gets about right there. I want to point something out.
1.
So pay attention when the balloon hits that position and see which way the nozzle is facing. It's like it's sucking its way forward. Or it's just reacting from that first push off the wall. Alright, we'll call this colossal fail number 2. If it was a singer, it'd be named Miley Ray Pseudo-Cyrus. No.
So what's cool about that is what that means is it doesn't matter whether you fly a rocket in the atmosphere or outside of the atmosphere. It'll still fly, it'll still go forward.
Now, like I said before, this ain't a hit piece against the Action Lab, but it's like he almost had me fooled with a couple coming up later on in this video. Like, you gotta really watch these videos, man. But this one here is nowhere near an example of thrust in a vacuum like that. And he's not a dumb guy, so this is borderline dishonesty.
Hey everyone, today I'm going to be dropping a feather and a coin in a long vacuum chamber to show you that they hit the ground at the same time. So the only reason that a feather and a hammer fall at different rates on Earth is because of the air around, causing more air friction on the feather than the hammer, and so the feather slows down a lot more than the hammer. So I have this long vacuum chamber tube. I'm going to be putting the coin and the feather inside of it and holding it on top with a magnet. I actually glued one little iron filing to the feather, so it actually barely.
So I'm going to take you straight to slow motion and show you that even with a little iron fouling, that they do not fall at the same rate, nowhere near the same rate. Now, I understand the principle that the air is going to slow down the feather, but look, that's nowhere near the same rate. By the time it hits the bottom, the feather's barely over halfway. Like, it's never been properly demonstrated. And how much more air could possibly be in there to slow that feather down? Like, this begs questions. And it also begs failure mimicking sound effects.
So the total pressure in the chamber is only around 0.02 atmospheres, which is so after it's glued, the only way the gas can come out is through the tip of the syringe. Once the gas starts pouring out, it should send the syringe flying in the opposite direction. Now let's try to ignite it by just holding our laser in one spot. Whoa.
If it's just action-reaction, no resistance involved, why did the syringe not move until the smoke got to the wall, till it streamed into the wall? We got zero movement at all. I'm bringing up the best examples because some of them aren't even worth mentioning. They're just obvious without even analyzing it. But every example they give us fails. They can show me any math, they can recite any rhetoric, say any words they want. It doesn't change the fact the syringe didn't move until the gas hit the container. And the NASA fanboys say that gases fall in a vacuum, so why didn't the smoke fall to the surface? I mean, it's common sense. Look at a balloon. As you lower the pressure in the chamber, the balloon expands in every direction. It doesn't get bottom heavy. This is just getting ridiculous.
Let's try a little bit bigger syringe and see if we can do it without destroying the rocket this time.
We have to keep showing these over and over because we're dealing with anti-flat earthers who are not honest people like McToon and others. They see with their own two eyes and they keep parroting nonsense.
Hey, it worked! Look how cool that looks. You can see the stream of smoke particles shoot. You can see the stream of smoke particles shoot.
So there it was, plain as day. The smoke is ejecting out the back and nothing's happening. Until it gets a bite on the wall, till it has resistance, it does not move at all. So this action-reaction in a vacuum is not valid. Oh! Oh!
3, 2, 1, go. Go, go. Oh! No! It failed. That produces thrust. So this is our 4th attempt, and what we did different this time is we made a rupture disc on the outside of the nozzle, and this is going to hold atmospheric pressure inside of that rocket motor until ignition occurs. And the idea is this thing's going to pop out and the motor's going to light, ignite, and burn normally. That's the key word, burn normally.
Okay, does anybody see any problems here? Just look at the little setup and not you flat earthers, I know you see the problem. Talking about the anti-flat earthers. Can you see any problems with this setup here in attempt number 4? Doesn't take rocket science to show the rocket scientists obvious problems. So for the 99% of Globers who didn't see the glaring problem, you see that seam right there? This is supposed to be attempt number 4 under vacuum. And there's a giant gaping hole, which I'm going to show the smoke pouring out of here in a minute. And for the few people who still don't understand, like Veritas and other anti-flat earthers, smoke in chamber not sealed, smoke leave chamber, chamber not sealed, smoke leave chamber. So all we've really seen is a bunch of fails. Why should we think it even works, even if you could produce one now? We've seen nothing but fail after fail after fail, but I'd still be interested in seeing one you claim works.